Hey there, this is the first lesson in the first unit in chemistry for this year. Unit 1 is going to be all about the atoms and the periodic table. So let's go ahead and get started. What we hope to accomplish today, hopefully you guys will understand properties of both metals and nonmetals, in addition to groups and families on the periodic table. Groups and families are the up and down columns on the periodic table, and they all have different names and different characteristics, so we'll learn about those. Atoms are a lot like Legos. Both are small units that can connect to build lots bigger things. And never trust an atom. They make everything up. I'm giving you a minute to think about it. Yeah, I thought it was funny too. Okay, so let's get started right away. Periods are horizontal. So the periods are the left to right rows on the periodic table. They tell the number of energy levels, and energy levels are where the electrons are located. And we'll talk a lot about energy levels later, but right now what we want you to understand is that you can tell the number of energy levels that an atom has by which row or which period it's in on the periodic table. What do the elements in the same period have in common? Well, they all have the same number of energy levels. That goes for all of them. Everything in period 4, in that fourth row on the periodic table, will have the same 4 energy levels. Groups and families are up and down. They're the columns on the periodic table. They're the vertical columns. Each group, up and down group, has the same number of valence electrons. So everything in group 2 will have 2 valence electrons. Everything in group 8 will have 8 valence electrons. Transition metals, which you see on your slide right there, they're the exception to the rule. The transition metals are all the white boxes. All of those have differing numbers of valence electrons, so you can't really determine the number of valence electrons by which period or which column they're in. Which group or which column they're in. So what do all of the elements in a group have in common? Same number of valence electrons. So everything in group 5 will have 5 valence electrons, 6 will have 6, and so on. The group number tells how many valence electrons that an atom has. If you see the Bohr models, those are the circles in the middle. The middle of each circle is representing the number of protons and neutrons. And you can't really see it because we're not talking about them right now. We're specifically talking about the valence electrons in the outer energy levels. For lithium, it has 1 valence electron, and it's in the first energy level, or the second energy level, because it's in that second period. Beryllium's the example for group 2. Group 2 has 2 valence electrons. Beryllium has 2 valence electrons. What you see below the Bohr models with the element symbol and the dots, that's called a Lewis dot diagram, and it just shows the number of valence electrons that each atom has. And the way you write a Lewis dot structure is you just write the element symbol and you put the number of dots that correspond to the number of valence electrons. So lithium has 1 valence electron. You'll see lithium's Lewis dot is Li, which is the symbol for lithium, and it has 1 dot to represent 1 valence electron. Nitrogen has, this is nitrogen's Lewis dot. You'll see nitrogen has the symbol N, and it has 5 valence electrons, and we show those valence electrons around the outside of nitrogen. Okay, periodic table can be divided into 3 main categories. There are metals, metalloids, and nonmetals. Those are the main categories. You have a periodic table that you can print, and it's double-sided, but it'll have, you don't have to print it double-sided, you can just have 2 different copies. One of them says side 1, and on side 1, we're going to color the different, the 3 categories. What you see here is a transition line. This heavy dark line right here separates the metals, which are over here on the left-hand side, from the nonmetals, which are over on the right. And the metalloids go right along that stair step. You can see here, these in purple are the metalloids. Okay, all of these are the metalloids on the periodic table, and you can color them the purple or whatever color you choose. They have properties of both metals and nonmetals, and they are right along that stair step line. On the left side of the stair step are metals, with the exception of hydrogen. Hydrogen is a nonmetal. So we've colored all the metals on the periodic table pink, and you can color whatever color you want. So all of these metals, all of these are metals. The purple are the metalloids, which leaves the turquoise color over here are the nonmetals. There's a lot of groups that we're going to ask, well, not a lot, 5 group names that we're going to ask you to memorize. They're actually pretty easy, and you probably know some of them, but there's several group names in these: the alkali metals, alkaline earth, transition, halogens, and the noble gases. And those are the ones that we're going to have you memorize. So if you turn your periodic table over to the other side, we can color the different groups. The group names that you need to memorize, again, we've got them here: metal, or alkali metals, alkaline earth, the transitions, the halogens, and the noble gases. The first group, those are the alkali metals. That's group 1. Group 1 is called the alkali metals, except for hydrogen. Hydrogen shouldn't be colored. I don't know why it is, but it is. But all the rest of them, from lithium on down to francium, those are alkali metals. One of the neat characteristics of alkali metals is that they're very explosive in water. So we have a video on the next slide showing you what happens when you put sodium in water. Let's see if I can get this video started for you. Oh, so you go back. There we go. Okay, this is up. You should see on your video. It says how sodium reacts with water. It's kind of a fun video. Let's see if we can get that for you.
Sodium metal in.
Okay, it reacts very violently with water.
So that's fire on top of water there. Little orange flame there. It's a ball here, you'll notice, round shape there. And that's because it has melted. And so that's actually molten metal there rolling around the surface. And notice it's all gone there when it's all reactive.
All right, so that's kind of fun. So the alkaline earth metals are the next group. That's group 2 on the periodic table. Everything in group 2 has 2 valence electrons. Now the alkaline earth metals, they are reactive, but they're not as reactive as the group 1 alkali metals. Alkaline earth metals can be used in things like fireworks. They're really bright and pretty. Magnesium produces a really bright light when it's burned. It says that it's used in pyrotechnics. Pyrotechnics is just fireworks. Photographic bulbs, and flares. And we try to get this video to work. For some reason it doesn't work. Okay, next we have the transition metals. I told you those are a lot. That's a big group. Everything in yellow is a transition metal. Down here on the bottom, we'll talk about in a second, they're lanthanides and actinides. They're the inner transition metals. One of the characteristics of transition metals is that they have varying numbers of valence electrons. So you can't always tell what their number of valence electrons is going to be. We can teach you that later, but right now you just need to know that transition metals have varying numbers of valence electrons. They also tend to be real nice and pretty and shiny, and a lot of them are used in jewelry. Here you'll see silver, and there's gold. Mercury is kind of cool. It's a liquid metal. It's very shiny. Oops, sorry. Went too fast. The lanthanide and actinide series, they're the 2 groups that are down at the bottom of the periodic table, below the periodic table. And we separate those out. They're still transition metals, but we separated them out because if you don't, it makes the bottom 2 rows of the periodic table really long and stupid looking, and nothing really fits together. So it was just easier to separate those out because as a group they share similar properties also. Okay, there's our metalloids again. Okay, right along that stair-step line like before. See, there's your stair-step. Right along there, and those are all the metalloids. These are halogens, fluorine, all the way down to astatine in the green. Those are highly reactive nonmetals. So group 1 is the most reactive metal group, and group 7A or 17 is the most reactive nonmetals. Group 18 or group 8A, those are the noble gases. They have 8 valence electrons, and they're fairly unreactive. They don't do much. Since they have 8 valence electrons and all atoms are trying to achieve that stable octet with 8 valence electrons, if you already have 8 valence electrons, there's no need to bond with anything else. So they tend to be very inactive and not react much. So here again, the group names again. Alkali metals, group 1 or group 1A, the most reactive metals on the periodic table. Then we have the alkaline earth metals in group 2 that are reactive but not as reactive as the alkali metals. Transition metals is that big huge group in the middle, largest classification on the periodic table, and they're usually found in ores. That's like they're in rock with metal, and they have to be mined out. You have to purify them and get extract the ore, the gold from an ore. Halogens, group 7 or group 17, they're the most reactive non-metals on the periodic table. And group 8A, they're inert or they're unreactive. They have 8 valence electrons. They're very stable, so they don't really react with other elements. Okay, properties of different elements. Using gold for an example, what are some element properties that you are familiar with? Well, color is one. Gold has a characteristic color, right? It's gold. It also will conduct electricity. Okay, it's a metal. Metals tend to conduct electricity. Here are the properties, though, that we're going to ask you to know. Metals are shiny or they're lustrous. Make sure you know that lustrous, what lustrous means. Just means that it's shiny. Down here we have a picture of aluminum foil versus some sulfur. And the sulfur is dull. It's a nonmetal. Most nonmetals are gases, but if they're solids, they'll be very dull and brittle. Metals tend to be conductors and nonmetals are insulators. Down here is an unusual picture. It's a picture of a window. So when mom and dad go and get new windows in their house, they're usually argon filled. So what that means is that there's 2 panes of glass, and in between the 2 panes of glass is argon gas because it's unreactive. So that keeps heat from moving in or out. In the summertime, you want to keep the heat out, and in the wintertime, you want to keep the heat in. So that argon gas in the middle prevents that heat from moving anywhere. It's an insulator. Metals tend to be soft and malleable. You can bend them with a hammer. Non-metals won't. They won't bend. What they'll do is they'll break when they're hammered. They're real brittle and they'll break like that. Metals can be made into wire, so they are ductile. That's what ductile means. It can be made into wire. And non-metals break very easily, so they are brittle. That's what brittle means. Across one period on the periodic table, metals have a higher density and nonmetals have a lower density. Here's some example of densities of different substances. Let's see, water, we know what water is like. So if you had some corn syrup and you poured it into water, what do you think would happen to the corn syrup? It would sink. So it's more dense than water is. If you had a piece of lead and you dropped it into the water and the corn syrup, well, it would go right through the water and then right through the corn syrup and sit on the bottom because it's more dense than either one of those things. Metals tend to have high boiling and melting points. It takes a lot of energy to heat them up and cause them to become molten or liquid. Non-metals have low melting and boiling points. I mean, look at that. Oxygen is already a gas, so it doesn't need a really low or really high melting point or boiling point. You don't need to memorize the properties of metalloids, but what I think is interesting is that all these metalloids are so pretty. They all look kind of the same. They have that real silvery, shiny color, but they'll possess properties of both metals and nonmetals, and they're varied in their properties. This creepy looking guy right here is Mendeleev. He created the very first periodic table. Mendeleev created the first one. Periodic means that something occurs in a pattern, and what he did is he used the properties of the elements that he knew at the time and he classified them. He discovered the patterns, and then he predicted patterns where there were no elements. So there were undiscovered elements where he knew there had to have been something that went there, but he just wasn't aware of it at the time. So it's kind of interesting. He worked a lot with very little tools. Mendeleev put elements in order of increasing atomic mass. So their weight was how he classified that first periodic table, how he put it together. Okay, here is a picture of what Mendeleev's first periodic table looked like. And what you see here is an empty spot. Okay, that empty spot is where Mendeleev knew that there had to have been an element that existed, but he didn't know what it was, so he left those spots where he knew something would go there. And he was right. Later on, we discovered those elements. Moseley is responsible for the current periodic table. Moseley took Mendeleev's periodic table and he rearranged it. He rearranged it in order of atomic number rather than atomic mass. When he put the periodic table in order of atomic number, which is the way it is now, those elements followed that same periodic pattern with very, very little change in atomic mass number. The masses kind of fell in line too. There's a couple of little spots on the periodic table, but not much. But the current periodic table, what you need to know is that Moseley is responsible for putting together the current periodic table, and it's put together based on increasing atomic number. In 2016, it was kind of cool. 4 new elements were discovered. It probably wasn't cool for you. It was very cool for us. We thought it was really neat. So we now have all 118 discovered, and I'm sure that's not a comprehensive list, but those are the ones that we know of. But those 4 down there in yellow are the ones that were most recently observed and discovered. So that's the end of our little presentation for day 1 on the periodic table. Make sure that you go through and do your homework so that you do well on the quiz at the end.